Hello everyone, good day. I'm Dang Hong Guang and my friend Patrick Lau. Say hi.
Hi.
Yeah, today we're going to present our assignment, which is solar photovoltaic renewable energy. And in introduction, in renewable power generation, solar photovoltaic as a clean and green energy technology play a vital role to fulfill the power shortage of the country. And solar photovoltaic system is able to supply electric energy to a given load by directly solar energy through the photovoltaic effect. They have two types of the solar power system. The first one is a standalone, which is consists the charging inverter DC-AC, battery bank, and other necessary AC appliances in common household or commercial application. And like this picture showing a standalone solar system, the solar panels are not connected to a grid, but instead are used to charge a bank of battery. This battery store the power produced by the solar panel, and then your electrical load draw their electricity from this battery. The second one is a grid connect solar power, which is one of that work in with the local utility grid, so that when your solar panel produce more solar electricity than your house is using, the surplus power is fixed into the grid. With a grid connect solar power system, when your house requires more power than what your solar panel are producing, then the balance of your electricity is supplied by the utility grid. And for the solar power system, they have a evolution of the technology. In the first generation, the PV panel was made of wafer-based cells, which is crystalline silicon, and the design is in single positive and negative junction. However, when going to second generation, the solar cells being created and can absorb 32% of the efficiency. And the second generation solar technology was born, which promising to overcome some of the technical and physical limitations. In third generation, the notable organic photovoltaic cells that aim to provide the greater efficiency while reducing the overall environmental impact of PV panel, and also to develop a highly efficiency, flexible organic solar cells that support effort to decentralize energy generation. Next, I'm going to present the energy process with respect to thermodynamics law. They have two types, which the first one is the energy model. The energy model of solar PV cells is based on the first law of thermodynamics, which shows that the solar radiation QS resists over the PV surface is partly reflected back from the top glass QR and partly absorbed by the PV module. And the absorbed solar radiation energy is distributed in the following component. First is the energy loss to the environment from the top glass through the radiation QRD and the convective heat transfer QC. And second is the useful heat energy from the back surface bottom glass of PV module, which can be utilized for heating purpose QU. And third is electrical energy PM. The energy balance of PV module is given by this equation: QS equal to QR plus QRD plus QC plus QU plus PM. And the SSG modeling of the solar PV is actually based on the second law of thermodynamics, classified into chemical and physical SSG model on the basis of nature of solar radiation, which is assumed to be particle, photon, gas, wave nature, thermal radiation, respectively. Based on the thermodynamic assessment, the SSG of incoming solar photon BS is equal to the sum of the SSG dissipated due to the reflection of photon back from the top surface BR, transmission of the photon through the solar cell BT, and the SSG absorbed in the PV cells due to the interbank electronic transition and the transition involving SSG absorbed in the PV cells is distributed in terms of thermal SSG output due to elastic phonon emitted from the PV cells BT and BTH, electrical energy output PM, and the entropy generation within the PV cell. Therefore, the expression for the SSG of incoming solar photon can be given as BS equal to BR plus BT plus PTH plus PN plus an entropy B. Next, I will pass to my partner.
Okay, good day everyone. My name is Patrick. I would like to continue our presentation as well. So now we will talk about the irreversibility analysis. The analysis of irreversibility on solar absorption refrigerator is present. Okay, the effect of external heat source temperature on the entropy rate and on the inverse specific cooling lot ISCL multiplied by a total area of the refrigerator. This may help a constructor to well dimension the solar machine under an optimal technical economic criteria and reasonable irreversibility on refrigerator. The solar concentrator temperature effect on the total exchange area, on the technical economical ratio, and on the internal entropy rate, it is going to improve. Next. So what is the proposal for increase this solar system efficiency? Okay, one of the available option is the solar PVT cogeneration system. Okay, system provide an alternative to utilize the extract heat from the panel. Okay, the panel efficiency might increase with the reductions in the panel temperature for particular isolations. And the reductions of power losses in the inverter can be achieved by the number of device count, the technology, the inverter topology. For this, an efficient multiple level inverter, MLI topology and nanofluids best solar PV panel is proposed. The proposed panel used titanium oxide nanofluid as a cooling agent. An efficiency and reliable inverter topology focusing on utilizing a single source is proposed. It is found out that the proposed topology utilizes only one DC source with the lowest device count, thus it has a lower cost and lower source losses. Next. So, what is the challenges for implement the renewable energy in Malaysia? First of all, it's project financing. Okay, country request enormous capital investment. Financial security is also one the biggest concern for renewable energy power purchase agreement. Does not offer enough cash flow for the bankers that lead to reduce the confidence between the banker and considerations of equipment investment. Okay, second, administrative and political barriers. Without a supportive political environment, no lower level of regulations can be established. A large number of organizations involved in permitting procedures and lack of coordination among involved the authorized. Absent of the powerful implementation of renewable energy policies that is mentioned in Malaysia's development plan. Okay, lack of the renewable energy specialists like the engineers, decision maker means that the policy maker are not seen to be fully aware of the characteristics and benefit the renewable energy. Next. Okay, again, the challenges is the market failure in assistance, inconsistencies in resource distributed by suppliers to resolve the customer demand. Okay, trend barrier come into play by imposes high price tax on the import renewable energy products such as the import duty. Okay, insistence of market failure, technological contract, lack of regular frameworks, and lack of the proper governance and non-institution measure, and finally, limited oversight of implementation and achieving target are to be concerned. Okay. Again, next, social and cultural barrier, limited public awareness on renewable energy technology, limited public awareness of renewable energy advantage in the daily life. Okay, the public feel that having the adequate fuels resource forever. Okay, existing low-cost energy for Malaysia resident like fuel, petrol. Okay, we can get it so easy. So for the public, there is not much of awareness on all this renewable energy. Okay, it is a high perception related by using the renewable energy. Okay, perception of unreliable high cost of renewable energy. Next. So now we will pass to my friends. Now I'm going to continue our presentations on the part of EIA.
Okay, now I'm going to present the environmental impact assessment. So there have four factors, okay, that are included. First one is ecology. Okay, in the that study was meant to determine the type of flora and fauna within the study area and in this vicinity. Okay, so the ecology we are consider because the ecosystem of the flora and fauna is very important. Okay, it may cause a temporary disturbance to residents, but with ground nest due to noise, dust, and particular emission, and possible illegal hunting by construction worker. And how we're going to solve it is the contractor is responsible for ensuring that the impact on the environment around the renewable PV solar power are minimized. The second one is about the air quality. So dust generation is resulting from the earthwork such as leveling, grading, excavation work, and movement of vehicle across the third and unpaved rock, especially during the windy condition. And also the exhaust emission of SO2, NOCO, and CO2 will be attributed predominantly to the operation of the construction plant and road vehicle, such as movement of truck and vehicle during the construction works. In order to reduce this problem, the contractors shall be committed to control emitted dust from such operation through the proposed dust emission control procedure described in the Environmental and Management Plan, EMP. And the third one is soil contaminant. So in the construction of the PV power, it may happen the soil contaminant also. The impact to the soil is waste generation for the construction material, accidental leakage of fuel, oil, or chemical stored within a burden area, causing a direct contaminant to soil, which may degrade the lower layer of the soil depending on the number of fields. So to reduce this problem, the proper spill response procedure implemented by the contractor will minimize the impact magnitude. And soil impact during operation phase are limited to accidental spillage of lubricant, fuel, and other chemicals that may potentially cause soil degradation. The fourth is waste generation. The improper management of non-hazardous and hazardous waste generated during the construction may lead to impact on soil, water, visual environment, in addition to the health and safety of workers. So in order to reduce all waste generated at the construction site, will segregate, handle, store, and manage as per contractor waste management procedure. Next, I will pass to my Patrick Lam.
Okay, I will continue the presentations. Malaysia national policy governing the technology. Okay, the government is expected to generate 5 billion in investment from solar power project by opening a tender for a capacity of 1,400 megawatt in year 2020. Such investment should be continued in future to keep the momentum. Actively promoting solar photovoltaic energy project and sustainability-related policy assessment incentive. Introduce an outdated energy framework and growing public awareness on net energy material, green energy, and sustainability indicate Malaysia's commitment to aim for a cleaner environment by avoiding carbon dioxide emissions. Offer tax break discount on electricity bills of 50% approximate as well as 4% trip EPF contribution by employee. Malaysia aim and focus on energy efficiency vehicle EEV by switching the conventional engine into eco-friendly energy vehicle. Okay, like Apple car. The air economy policy and government-linked company involved in fuel market economy policies and blue ocean strategy employee to promote the development of renewable energy. The Ministry of Energy, Green Technology and Water Malaysia is developing the renewable energy transitions roadmap 2050 as a substitute to the current national renewable energy policy and also the action plan. Next. So, in the conclusion, the solar energy is a great alternative energy source, which is the cleanest and most abundant renewable energy source even available. In Malaysia, we still have a long way to achieve the 20% target use of renewable energy in our generation mix by 2025. Although the current trend seems to be quite positive, but we need to continue to put in more effort, okay, to make the boost of renewable energy sector in Malaysia as well. Okay, thank you everyone. This is about our presentations. Okay, thank you.